Welcome to topic parameter pausing techniques. Parameter pausing techniques. In the last two sessions, we discussed about what exactly is modularity, what are the advantages of modularity, what are the disadvantages of modularity, and how the C language supports modularity using functions. What are the general syntax of functions, or signature of functions, prototype of the functions, and we discussed what is the difference between interface and implementation, and declaration and definition. So these things we discussed in the last session. We also actually discussed we can pass parameters. We can pass parameters to the function, and we can avoid the parameters also. Suppose it is a function, some function, say the name of the function itself is function. So in that case, you can call the function without parameters, or you can pass some parameters. Okay, you can pass some parameters. So functions can be written with parameters and without parameters. Now, if we pass parameters, and if we manipulate the parameters in the function, then what happens? That is all about parameter pausing techniques. So how do you pass the parameters, and are you permitted to manipulate within the function? What is the net effect of that manipulation? Will there be any effect within the called function or not? You have calling function, called function. So a function is called, parameters are passed. Within that function, you may manipulate the parameters. What is the net effect? Of it in the called function? So that we are going to discuss in this session. So in C, functions can be written with parameters and without parameters. Whenever we want to pass some information, which is the function uses it in some way, then we pass parameters. So why do you pass parameters? Because you want to pass some data to the function, and that function uses that data. In that case, you make use of parameters, and you pass the information through the parameters. The parameters can be any type, including the basic data type supported by C language, and also user defined data types, and also derived data types also. The number of parameters can be 0, 1, or multiple. But the number of parameters and the number of arguments that are passed to the function should match. The number should match. Also the type should match. And there will be a mapping between the parameters and arguments through position. Programming languages may vary on how the mapping is done in different languages. It may be done in different ways, and different programming languages may support different types of parameter pausing technique. So now we will discuss this concept, the number, type, and position. Okay, here you can see an example. Okay, what are these? These are A, B, here are called as arguments. A, B here are called as arguments, or actual parameters. A, B are called as arguments, or actual parameters, Okay, now these are called as XY. These are called as formal parameters, or simply parameters. So when we use the term arguments, we just simply call them as parameters. Arguments, parameters. Whereas in some books, this will be called as actual parameters, and this will be called as formal parameters. The number should match. Here you can see there are two arguments, so there should be two parameters. That matching is required. Matching is required. Okay. Two arguments, two parameters. Number matching. Okay, number of parameters matching. Now type of parameters. Here you can see this x and y are integers. Similarly, a and b are declared in this function as integers. Okay. So the type of parameter should match. The type of parameters should match. Now the mapping. So that means a is mapped to x, b is mapped to y. So that's why the mapping is by position. This is the in first position, so first parameter. B is in the second position, so second parameter. So that's how this mapping is done. Okay. So here we are calling the function. Function is definition is here. Function definition here. Of course, before actually calling this function, we should declare it. Before main, we will declare it. We will see in the programming example. We have to declare this function. So actually, the return type should also be is also necessary. So if you avoid it, it will be taken as void. For some compilers, void is also compulsory, so we have to mention it. But we'll get to that point. But function, this is called as function definition, where you write the name of the function, parameters, etc., and you write the actual code. That is called as function definition. So here at this point, you are invoking the function or calling the function. Which function you are calling? You are calling this function. So main is the calling function. Sorry, this is called as called function. Main is called as calling function, and this function is called as called function. So a and b are called as arguments, x and y are called as parameters. A is mapped to x and b is mapped to y. Note that the number and type of the parameters match. So two parameters, two arguments. Sometimes a and b are called as actual parameters, x and y are called as formal parameters. So coming to the actual point, parameter parsing techniques. There are 5 parameter parsing techniques: call by value, call by reference, call by value result, call by name, and call by test. We are not going to consider all these parameter parsing techniques. That is a more broad topic. So we will restrict ourselves to the 2 parameter parsing techniques that are supported by the C language. 2 parameter parsing techniques that are actually supported by the C language. The 2 parameter parsing techniques that are supported by the C language are call by value and call by reference. By default, it is call by value. Call by reference is supported. Using what are called as pointers. That is the next module actually. So in this session, we will restrict ourselves to only call by value. We don't discuss the examples related to call by reference. But we will discuss the concept. But we don't discuss the examples. So the 2 parameter parsing techniques that are supported by the C language are call by value, call by reference. So call by value parameter parsing technique is a simple parameter parsing technique without any side effects. Now what are the side effects? We'll see. So it is a simple parameter parsing technique. In call by value parameter parsing technique, the value of argument is copied into the location of the parameter. Try to understand that point. The value of the value of the argument is copied into the location of the parameter. The value of the argument is copied into the location of the parameter. So within the function, only location of the parameter is accessed. You cannot access the location of the argument actually. If you modify the parameter, the value in the location of the parameter is modified. The value of the argument is not modified as its location is not accessed. As its location is not accessed. As its location is not accessed. So I will show it in diagrammatic form. Because that is there in the slides. I will discuss at that point. So what do you mean by side effects? What do you mean by the value of the argument, location of the parameter, and why the argument is not modified actually? The pros and cons. So any modifications to the variables is explicit. This is one of the good programming practices. So if you modify anything, that modification should be explicit. That means, say, by assigning a value, say if a equal to 10 means you are explicitly assigning a value 10 to the a. Somehow if the a content is modified and you don't do it explicitly, then it's a problem. So that is modification due to side effect. Due to side effect. It's always better to avoid side effects. The cons means, so we discussed that the value of the argument is copied into the location of the parameter. The value of the argument is copied into the location of the parameter. That means you are copying it. Already in memory that argument values are stored, and those values are again copied into new locations. That means you require extra memory for the parameters. So, okay, if we have two variables, say a and b, and parameters x and y, so a, b locations are there, x, y locations are there, you have copied it, fine. But imagine, say, you want to pass 1000 values using array or directly, whatever it may be the case. So in that case, what happens? So 1000 argument locations are there. You have to create 1000 parameter locations and then copy the content. So that is considered as a overhead. So this is the diagrammatic representation of call by value. Function AB. And here you can see this is the function actually. This is the function AB. You are passing a and b as arguments, x and y are the parameters. So you can see here what is happening. So this is the argument location. Some value is there. Okay. That value is actually copied into the location of the parameter. This value of a is copied into the location of the parameter x. Similarly, the value of argument b is copied into the location of the parameter y. Suppose if this is 10, so if a is 10, then when you call this function, what happens is this value 10 is copied into this location. Similarly, assume that b is 20. So that is actually copied. So 20, that is actually copied. Okay. Now within the function, these locations are accessed. Within the function, that means at any point here, so if you try to manipulate x and y, if you try to manipulate x and y, these locations are accessed. These locations are accessed. Okay, but the another point you have to note is, so the values here are never copied into these argument locations. You may manipulate them. Say you may manipulate them. So within this function, say there is some statement like say x equal to x plus 1, and also say there is another statement called y equal to y plus 2. So in that case 10 is copied, and because x equal to x plus 1, x value is incremented, so that means it becomes 11. Similarly the case with the y copied here, and this value is manipulated, so this becomes 22. So within this function, if you print the values of x and y, if you print the values of x and y, 10 and 20, 11, actually this is 11, because let me just erase it. This becomes 11. This becomes 22. So within this function, if you print the values of x and y after these statements, then x value will be printed as 11, y value will be printed as 22. But after executing this function, if you come here into the main, and if you access the values of a and b, the values of a and b will be 10 and 20 only. So because there is no reverse copying, and both are not referring to the same location. A location is different from x location. Okay, this point you remember. So for all the simple parameters, these integers, characters, float, double, etc., call by value parameter parsing techniques is used. So the values of these arguments are copied into the locations of the formal parameters, into these parameter locations. Okay, but the reverse copying doesn't take place. You can just have a snapshot. Of it, because you don't find these diagram in your books. Call by reference. So in call by reference technique, the address of the argument is copied, and both the argument and parameter refers to the same location. That is important. The address of the argument is copied, and argument and parameter refers to the same location. If you modify the value of the parameter, the value of the argument is also modified, since we are accessing the common location or same location. So that means here in the case of call by value, the argument location and parameter location are different, whereas in the call by reference, argument location and parameter location are same. Both will be referring to the same location. So here you can see this concept we have not discussed it actually. These are called as pointers. This we will discuss in the next module. But what exactly happens is, so this is the location. So A will be pointing to this one. That means, so whenever you use the value of A, whenever you try to access the value of A, whatever present here, it will be accessed. Similarly, X is also referring to this same location. So common location, this is common location. Common location. Now what happens? Suppose if initially A is 10, A is 10, again similar to the previous case, A is 10 and B is say 20, B is 20, then what happens? If you manipulate here using say x equal to x plus 1, x equal to x plus 1, and also y equal to y plus 2, y equal to y plus 2, then what is happening? Because both are referring to the same location, x is also referring to the same location, so x equal to x plus 1 means x equal to x plus 1 means x value will be incremented and x value becomes 11. X value becomes 11. And y equal to y plus 2 means y equal to y plus 2 means because it is referring to the same location, y equal to y plus 2 means it becomes 22. It becomes 22. Okay. So both are referring to the same location. If you print the value of x and y here, 11 and 22 are printed. But even after returning to the function, this main function, after this function call, if you print the value of A and B, 11 and 22 will be printed because both are referring to the same location. So you remember this diagram. This will give you more clarity. This will give you more clarity. Because in books it is not explained properly. Take a snapshot. So that is the difference between the call by value and call by reference. So call by value, call by reference results in less storage because we are accessing the same location or common location. Okay. And it will be useful whenever you want to pass large amount of data. Definitely you want to prevent copying of the data, so it is more useful in those cases. The modifications are implicit, not explicit. So you are actually manipulating the value of x. What you are manipulating actually? Here you are within this function, you are manipulating the value of x. You are not manipulating the value of a. You are manipulating the value of x. Because a and x are referred to the same location, a value gets automatically modified. So the modification is called as implicit modification. Implicit modification. So the modification is implicit, not explicit, and it is considered as a side effect. And it is better to avoid. It's better to avoid. So in C, call by reference is supported through pointers. Also, call by reference is used when array is passed as a parameter. When array is passed as a parameter. So pointers we'll discuss in the next module. Arrays we have already discussed, but we have not discussed how to pass arrays to functions. So there is interdependency between all these topics: arrays, pointers, functions, etc. So actually, I am not discussing it in these modules. So I have at the end I have a separate module where we'll discuss this combination of all these concepts: pointers, functions, pointers, arrays, arrays, functions, arrays and functions, etc. So those things we'll discuss at the end. So for pointers, call by reference is used. For array also call by reference is used. For in all the remaining cases, call by value is assumed. Call by value is assumed. You can see here simple example. So this is the main function. X and y are declared. You are reading the value of x and y. So you are calling the function called as sum. So here you can see this is the function declaration. This is the function declaration. This is function declaration. Here you can see we are not writing the actual code. We are just terminating it with the semicolon. Okay. If you want, you can write the code also here. If you want, you can write the code also. Instead of writing semicolon, you can write code here directly. But generally what we do is we want main to be the first function. We want main to be the first function. So that's why we just declare. We just declare. So we just declare like this. Okay. So what it is doing, I think it is computing the sum of x and y. So the actual code you can see here, you have written after the main function. After the main function, you can see here, main started and closed. After the main function, you are writing the code. So here you can see you are not writing the semicolon because you want to write the code. So you are adding the values of a and b, and then you are returning return c. That means the value of c is written back. So because the value is written, there should be some LHS, left hand variable, which is capable of storing the return value. So z, because sum of two numbers integers is integer, so z is also, I think here it is missing, z has to be declared. Z has to be declared. Z has to be declared here. Z has to be declared here. Okay, Z has to be declared here. So Z is also declared as integer only. Okay, now here we are not manipulating. Now again I will re-explain these things. Suppose here before written, suppose you have statement like a equal to a star 2. So in that case, what is the value of a? Suppose assume that the value of a is the value of a. That means the value of x in that function, the value of x in that function, main function, is 10. So a gets the value of 10. So a equal to a star 10, that is 20. So if you print the value of a here, if you print the value of a here, 20 will be printed. But after going to the main function, if you print the value of x, only 10 will be printed. Okay. So that is called by value. So learn to organize, deputize and supervise. This is essential because we are discussing about the functions. All the functions one cannot do. All the tasks one cannot do. So we have to ask different people to do different functions. So if you want to prevent burnout, actually, psychologically, if you want to prevent burnout, learn to organize, deputize and supervise. Don't try to do everything on your own. Some people try to do everything on their own. So it will result in what is called as burnout. You get exhausted. So learn to organize, deputize and supervise. So that is regarding the functions. We'll stop here. We will discuss the next, the programming example. So we'll discuss all these concepts, how to implement what we have discussed through programs, we will discuss multiple programs. So see you in the next session.